Z1 equals 2 plus 2I root 3, and Z2 equals minus 1 minus I root 3. Evaluate Z1, Z2 as in the product using their Cartesian forms. Evaluate Z1, Z2 using polar forms. So convert them to cis form and then multiply them that way. Verify that the two results are the same. Okay, so if we start with the long way around the Cartesian form, part A, we need to do Z1, Z2. So Z1, Z2 equals, Z1 is 2 plus 2I root 3 plus 2I root 3 multiplied by Z2, which is minus 1 minus I root 3. So both of those brackets have got common factors in them. But for the first one you can pull a 2 out of, and the second one you can pull a minus 1 out of. So I'm actually going to do both of that. So I'm going to say that is minus 2 times 1 plus I root 3, 1 plus I root 3. Okay, so then we've got a perfect square. So we've got minus 2 times 1 plus 2I root 3, 1 plus 2I root 3 plus, and then you've got I squared times root 3 squared, or I root 3 squared, equals, I better close that bracket, so minus 2 times I root 3 squared, well I squared is minus 1, root 3 squared is 3, so minus 1 times root 3 is minus 3, so we've got minus 3 here, 1 plus 2I root 3, or 2 root 3I. So now this equals, the 1 minus 3 is minus 2, minus 2 times the other minus 2 is 4, minus, then you've got 2 times 2 is 4, it's minus 4 root 3I, minus 4 root 3I, okay? So that is the product using Cartesian form. For polar form, we're going to have to work both of these numbers out in cis form. So Z1 equals, well it's 2 times, so 2 brackets, 1 plus root 3I, 1 plus root 3I, and Z2 equals minus 1 minus root 3I. Okay, so if we draw a little Argand diagram for both of them, remember that's the real axis and the imaginary axis. 1 plus root 3I, so the 1's here and the root 3 can be here. 1, so somewhere like that. There's your complex number. Remember, we want the argument, you can see it's going to be positive. Everything in the first quadrant. So tan, we call that theta. Tan theta equals root 3 over 1. And if you use your hand, you know that when theta is 0, 30, 45, 60 degrees, tan theta is root 3 over root 1, root 3 over 1. So 60 degrees equals pi by 3. So the argument of Z1 equals pi by 3. The modulus of Z1, well, it's going to be 2 times the square root of the real part squared plus the imaginary part squared, so 1 squared plus root 3 squared. Okay, so 1 squared is 1, root 3 squared is 3, 1 plus 3 is 4, square root of 4 is 2, 2 times the other 2 is 4, so the modulus of Z1 equals 4, so that means Z1 equals 4 cis pi by 3. Okay, if we do something similar for Z2, real part and the imaginary part. So for Z2, it's minus 1 minus root 3I. So it is minus 1 on the real axis and minus root 3 on the imaginary axis. So it's down here somewhere. Okay, so the argument is going to be this angle here. So that is going to be a bit more challenging. One thing we could do, we could just go back into this quadrant here. I've not drawn it brilliantly, but if you think about it, well, actually we've got the same values before. So if this was 1 here, this would be 1, and this would be root 3 up here, which is exactly the same as, or drawn differently. In fact, the second one's drawn better. We're looking at pi by 3 here. Pi by 3, okay, so that's 60 degrees. It's 60 degrees. So the actual argument of Z2, well, it's going to be this. If this was 60, the whole thing, this leaves 30 in here. So this must be 30. We know that's 90. 90 plus 30 is 120, so minus 120. Remember, pi equals 180. 60 is pi by 3. So 120 is 2 pi by 3. And we said it's minus, it's negative because it's going that way around, it's going clockwise. So the argument of Z2, equals minus 2 pi by 3. Okay, the modulus of Z2 modulus is going to be, 1 squared plus root 3 squared, the square root of that. 1 squared plus root 3 squared. 1 plus 3 is 4, square root of 4 is 2. Okay, so that means Z2 equals 2 cis minus 2 pi by 3. Okay, so now we've got them in polar form. We can do Z1, Z2. So when you're multiplying together two complex numbers, and they're both in their polar form, their modulus argument form, you multiply the moduli. So you have the modulus of the first one, the modulus of the second one, you times them together. So the two moduli are 4 and 2, so we're going to do 4 times 2. Times, and then we add the arguments, so times cis, we add the arguments, so that it is pi by 3 plus minus 2 pi by 3, so pi by 3 minus 2 pi by 3, because we're adding a negative. So pi by 3 minus 2 pi by 3 is minus pi by 3, so that equals 8 cis minus pi by 3. Okay, so if we draw a little circle, and the cis means cos pi by 3. Remember, 8 cis minus pi by 3 equals 8 cos minus pi by 3 minus I sine minus pi by 3. Okay, this is the same. We're supposed to verify that these are the same. So minus pi by 3 is here. That's 60. So we know that at 60 degrees, the parent angle, cos 60 is a half, sine 60 is root 3 over 2. So if we go down to the negative, cos is going to be the same, a half, and the other one's going to be minus root 3 over 2. Okay, so that equals 8 times cos minus pi by 3 is a half, plus I sine minus pi by 3, so that's going to be plus I times minus root 3 over 2, so it's minus root 3 over 2 I, right? So that is going to equal 8 times a half is 4 minus, and then you've got 8 over 2 is 4, so it would be minus 4 root 3I. Okay, and you can see that that is exactly the same as the result we had when we multiplied them using our Cartesian form, so we can just put as required. Because we were asked to verify that these two results are the same with the two different methods of multiplication.